Now see here what is adiabatic change or adiabatic process. Now see here a change in the pressure and volume of a gas in which temperature also changes is called an adiabatic change. So see here, if you have taken gas in a cylinder, you are taking an ideal gas in this cylinder, a frictionless piston is fitted here. When the gas is allowed to expand or the gas is compressed, if the walls are suppose non-conducting, these are the adiabatic walls and the piston is also non-conducting. So, there is no exchange of heat between the system and the surrounding. It means in this case delta Q will be equal to 0. So, no heat will be supplied from the outside, even though no heat can go out. This type of the change is known as adiabatic change. So, when the gas expand here, so P, V and T, all these three parameters changes. So, there are two necessary conditions to take place adiabatic change. First one, walls of the container must be perfectly non-conducting, that means adiabatic walls, and also the expansion or compression of gases should take place very fast, that should be, it means sudden, so that there is no time to exchange the heat between the system and surroundings. And certain examples you might have seen is here. One is bursting of tires. Say in summer, basically what happens, sometimes the tires of the cars or the bikes get burst. That is also the sudden expansion of the gases, that is an example of adiabatic change. And also if there is the steam in the cylinder of the engine, steam engine, there is a sudden expansion of the steam, that is also an example of the adiabatic change. Now say in adiabatic change, the relation between P and V for an ideal gas is given here. PV raised to power gamma is equal to constant. See here, gamma is equal to, written here, Cp upon Cv. Cp is here a specific heat at constant pressure and Cv is the specific heat at constant volume. We also need know here PV is equal to RT for 1 gram mole of the gas. So, we can write here P is equal to RT upon V. If you replace this value over here, you will be getting RT upon V into V raised to power gamma is equal to constant. So, here we can write T V raised to power gamma minus 1 and this R will be coming here. So, constant upon R is also has a constant value. So, that will be a new constant. So, it is also here the constant. So, we can write here TV raised to power gamma minus 1 is constant. So, this is the another relation for this one adiabatic change. And also we can go if we replace V. Suppose if you replace V from here, so you will be getting V is equal to RT upon P. So, replace the value of V. So, P is equal to RT upon P, gamma is equal to constant. So, you will be getting here P raised to power gamma here. So, P raised to power 1 minus gamma into T raised to power gamma is equal to constant again. So, that is a new constant. So, we can write a constant only. So, this is the another relation. So, these are the different relations for the adiabatic change.